Did you know that a really fast chemical reaction makes riding in a car more safer? Most cars have airbag built into the dashboard and the steering wheel that can blow up like super fast like balloons during a collision and cushion riders from getting hurt. What makes the airbag blow up like a balloon? It's chemistry. Instead of transporting compressed gas in the car to inflate the airbag, we take advantage of the very fast reaction that produces the needed gas.
Chemical reactions involved in car airbags by Group 5.
Overview of how airbag works. Timing is crucial in the airbag's ability to save lives in a head-on collision. An airbag must be deployed in a matter of milliseconds from the initial collision impact.
Advantage of car airbag. Airbags are used as a protective device for the users of cars. Airbags have saved lives and have lowered the number of severe injuries. Disadvantage of car airbag. The chemical components of airbags have a bad effect on the user, and sometimes the reaction is not stable or unexpected. The chemistry behind airbags. The chemical reactions are used to generate the gas inside an airbag. Many car airbags inflators contain small amount of toxic molecule called sodium acide or NaN3, one sodium atom and three nitrogen atoms combined. Sodium acide breaks down very quickly when heated or physically shocked. This is called decomposition. The products of decomposition are sodium atoms and nitrogen gas. If the car is involved in a collision, sensors send an electrical signal to the container where the sodium acide is located. The signal ignites a flammable compound and the heat rate starts the decomposition of the sodium acide.
A huge amount of nitrogen gas has immediately rushes out with an explosion and fills the airbag. It is amazing that from the time the sensor detects the collision to the time the airbag is fully inflated is only 30 milliseconds or 3/100ths of a second. A normal blink of your eye is 100 milliseconds, around 50 milliseconds after a collision. The person riding in the car hits the airbag, which absorbs their forward moving energy and protects them from slamming into the other parts of the car. Chemistry has saved the day. A relatively small amount of sodium azide, 4.6 ounces or 130 grams, will produce a lot of nitrogen gas very quickly. It takes almost 5 party balloons worth of gas to fill a normal airbag. The sodium metal product can be a potential hazard, but in this case, other ingredients react with the sodium to form safe compounds.
There are three reactions involved in the deployment of an airbag: sodium iodide, potassium nitrate, silicon dioxide are the initial reactants packed into the airbag module.
In the airbag reaction at initial reaction triggered by sensor, the reactant is sodium azide, and the products are sodium and nitrogen. At the second reaction, the reactants are sodium and potassium nitrate, and the products are potassium oxide, sodium oxide, and nitrogen. At the final reaction, the reactants are potassium oxide, sodium oxide, and silicon dioxide, and the product is glass.
It produces harmless nitrogen gas that fills the airbag. While it is coming out, the nitrogen gas expands and undergoes a process that lowers down the temperature and removes the combustion. The chemical inside the airbag that is responsible for the spontaneous reaction is called sodium azide, NaN3. Sodium azide is stable at room conditions, however, when heated it breaks down. The chemical reaction behind airbags is as follows: 2Na-N3 into 2Na plus 3N2.
In the above reaction, the second product is N2, which is also known as nitrogen gas. As nitrogen gas occupies a large volume, so a handful of sodium acide, or 130 grams approximately, will produce enough nitrogen gas required to inflate an airbag. That is the main chemical mechanisms that happens in a span of 30 milliseconds inside an airbag. But it's not only one. In the reaction, The first product produced is sodium, or Na. It is highly reactive metal and will immediately react with the water to produce sodium hydroxide, or NaOH. Sodium hydroxide is a toxic compound. It will be very harmful if it comes in contact with the eyes, nose, or mouth. To avoid such a dangerous situation and to minimize its exposure, other chemicals are mixed with sodium acid to dilute the reaction of sodium, which is return produces less toxic compounds during the chemical reaction.
To detect a collision or an impact, there are sensors in the front part of the automobile. These sensors send some electrical signals to the container that contains the sodium azide and detonate it, resulting in ignition. The heat generated from this ignition reacts with sodium azide and it starts breaking down into sodium and nitrogen. In the end, the nitrogen gas fills the airbag. One of the most interesting things is that all of the mechanism, right from the time the sensor detects the collision till the inflation of the airbag. All of this happens in 30 milliseconds, which is around 0.03 seconds. So, we can say that after 50 milliseconds of an incident, the airbag are inflated and protects the passengers by absorbing their forward-moving energy.
Isn't it amazing how chemical reaction happens? Now you know what happens inside an airbag. If the car is involved in a collision, sensors send an electrical signal to the container where the sodium acid is located. The signal ignites a flammable compound and the heat it creates starts the decomposition of the sodium acid.